everybody. So I'll be talking about my research. Today I'm Paulo Setti, a PhD candidate at the Geophysics Lab here at the University of Luxembourg. And my topic of research is Spaceborne GPS reflectometry for land applications. And these land applications include soil moisture and inundation extent. So the soil is composed mainly of three components, which are the soil grains and some empty spaces between them, which can be filled by either air or water. And then the soil moisture is a component of the water cycle and is the volumetric water content in a soil sample. Having precise estimates of the soil moisture is very important in a wide range of applications. Because, for example, with the soil moisture that determines the infiltration and runoff of water after rain event. It is also important for landslides, risk assessment, for hydrological drought monitoring, and it also affects where and when places might get flooded. And this water is constantly exchanged between the surface soil and the atmosphere above it. If we want a precise weather forecast model, then we need precise soil moisture information. And monitoring inundation extent is also really important. After a severe rain events, for example, we can help first responders and governments. And wetlands, which are land areas that are saturated with water, either permanently or seasonally, they produce methane, which is a global warming potential gas. So it's really important to monitor this kind of stuff. I don't know who's controlling my slides. If you want to go to the next one, please. And the next one. Thank you very much. So we have different techniques that we can use to monitor soil moisture. We have some in situ devices that can measure it, but the problem is that they can estimate the soil moisture for a small region around the station, and also it's very expensive. And then we have some huge, very, very expensive satellites that measure soil moisture. But the problem is the temporal and spatial resolution. We have observations every 2 or 3 days, and also the footprint is 40 kilometers. So it means we have one observation, a mean observation in 40 by 40 kilometers. For inundation extent, we can also use satellite images. But the problem is that inundation usually occurs after a rain event. So it means that the sky will be covered by clouds and will not see anything in this image. Next slide, please. So then comes the Spaceborne GPS reflectometry. So GPS, we all know what it is. We use it every day in our phones to get our position. And the way the system works is that it measures the time a microwave signal takes to travel from a satellite to our phones. But in my research, we are using the GPS reflectometry, which in this case, we're not using the direct signal, but the reflected ones. And what is interesting about the reflected signals is that when they reflect, they carry some information about the place where it's reflected from. We have different missions for reflectometry. For example, the Cygnus mission from NASA, and Spire also has a constellation of GPSR satellites. And in the figures in the right-hand side, you can see the coverage of Cygnus mission, for example. And then with 5 days of data, we can cover almost the whole equatorial area. Next slide, please. So based on that, the objective of my research is to work on a method for multi-sensor data integration for soil moisture and inundation extent estimation. And by doing so, I can take advantage of the strength of each of these different methods. And in these figures, I show some of my results. For example, on the left-hand side, you can see the power of the reflected signals over Amazon rainforest in South America, and we can clearly see and delineate the rivers, even if they are below vegetation. The top right-hand side figures show the power of the reflected signals in a wetland, a tropical wetland, in a rainy and in a dry period. So you can clearly see how it changes over time, the reflected signal. And the bottom figure just shows a time series of a soil moisture estimate in a location, and it correlates really well with the reference data that we have. I think that's all I have time for now. The next slide, please. Yeah, thank you very much for your attention, and if you have any questions.